A very good morning. My name is Bynum Chaderick and I'll be taking you through Introduction to Machine Learning in Python. I'll be explaining the brief overview of the concepts, methods, and application, and then my colleague will take you through the rest. Now, machine learning in simple terms is about teaching computers to learn from data instead of being explicitly programmed. Now, we can take an example of the machine of detecting spam emails, where we have to write a rule that is detect we have to write every rule that is to detect the spam emails. Now this will be nearly impossible because spam evolves continuously, because if you had said that you have to detect this type of spam email, this type of spam email, no, it wouldn't be possible. Now with machine learning, the system analyzes the data in form of flagged emails and discovers the pattern automatically, and with time it adapts to the new data, becoming more accurate without any human intervention or without any programmer teaching it to do so. And now we have to know that machine learning is behind very many innovations, such as voice recognition systems like Siri, Alexa, and recommendation systems, maybe on Netflix, YouTube, and Amazon. So yeah, you're going to understand why machine learning was invented. And now in order to understand why machine learning was invented, you have to compare it with another form of programming, which is traditional programming. And now in traditional programming, you have to analyze the problem, manually write the rules, test them, and repeat the process until the system works. And this can be tedious and unstable for complex and dynamic tasks. So machine learning shifts from this approach, and that it for machine learning, you have to you're, you're going to provide the data, and the algorithm is going to learn by itself. It's going to learn by itself, and then after learning, once you keep on teaching, it is going to become more accurate and be efficient. Now, This is more like teaching a child to separate two animals. If you're teaching a child to learn that this is an elephant and this is a cow, you have to show the child the images, and he'll know that the cow has horns on the head and the elephant is big and has tusks near the nose. Now, the types of machine learning, there are two. You have the supervised learning and you have the unsupervised learning. Now in supervised learning, we use labeled data sets where each input is paired with a correct output. And for example, you can use that in prediction of house prices based on features like the prices, the price and the location of the house. No, the size and the location of the house. Sorry. And now in supervised learning, you have tasks like regression and classification, which we may not talk about briefly because of time. Then you have unsupervised learning, which uses unlabeled data sets. An example which I can give here, which is based on the clustering, which is among the tasks, is grouping customers based on purchasing behavior in order to tailor marketing strategies. And this can be used in companies, maybe in order to monitor their market value and such stuff. And we can differentiate these two types of machine learning using the difference that supervised learning uses labeled data sets and unsupervised learning uses unlabeled data sets. And now we can talk about linear regression as an example of supervised machine learning example or technique. And you have to know that linear regression is one of the simplest supervised learning techniques, and it predicts the target value by modeling the relationship between the feature and the outcome as a straight line. And now, linear regression is widely used for problems involving numerical continuous targets such as stock prediction or energy consumption. So maybe like in the Ministry of Energy, so we can use linear regression in order to predict maybe how people are using energy, such stuff. And the key components we have in linear regression, you have the prediction model, you have the cost function, and you have the optimizer, where the gradient descent is used to minimize the error between the predicted and the actual value. And this helps when you keep on constantly doing this, it's going to make the model become as accurate as possible. Next, we're going to talk about the end-to-end machine learning, and we have to know that building a machine learning model is a structured workflow, and it involves following sequential steps. And now this brings me to a concept that is machine learning pipeline, where we collect the data, which is an important step where we have to collect good data. Once the data is poor, the machine learning model won't be efficient. Then after we clean and pre-process the data, where we ensure that any missing where we ensure that there are no missing values. Then after we choose the machine learning model, and then we train it on using historical data to enable it to learn. Then after training, we are going to fine-tune the model. In that way, we are going to optimize the parameters in order to improve its performance. Then finally, we are going to deploy the model into production environment and continuously monitor its performance in order to adapt to the data. Now, we are doing all this workflow in order to make sure that the system isn't just theoretical, and in that it works effectively in real world application. Is that if it's embedded in a system, it is working perfectly. So we're going to talk about exploratory data analysis, which is the EDA. Now, we have to know that EDA is a critical step before applying machine learning algorithms. It helps us understand the data structure and identify any potential issues. For example, if we are to check the number of observations and features, where the features are numerical or categorical, and if any features need scaling, we have to use visual tools like histograms, which help us to detect any outliers and abnormal distributions. And next, we're going to talk about the KNN, which is the k-nearest neighbors. Now, this one is an intuitive and versatile algorithm. It works by measuring the distance between the data point we want and to classify all the other data points in the data set. For example, if we are to classify a new flower, KNN looks at the K closest flower based on the features like petal length, sepal length, and width, and the majority vote among these neighbors determines the new flowers category. And these are the pros and the constraints in the slides, and the main uses, which is text main agriculture, finance, and cargo competitions. Then lastly, we're going to talk about the decision trees, where we classify the data by splitting it into smaller groups based on feature values. Then each split is chosen to maximize the information gain, a measure of how well a feature separates the data. And then the advantage is in that it is easy to interpret and visualize. The limitations, it is prone to overfitting. Now, decision trees are easy to visualize, as I talked about in the advantages. However, they can overfit, especially with noisy data. Now, this is where techniques like pruning come in, which simplify the tree by removing less critical splits. Despite their challenges, decision trees are widely used in applications like credit scoring and the customer analysis. So that's it from me. And that's it for introduction to machine learning in Python. Then my colleague will take you through the other parts. Thank you.
Hello, my name is Katunja Brendan. I'm going to talk about modules 5, 6, and 7 of the diploma in machine learning with Python. To start with, we have the assembly learning. This one is about combining many weak modules into one super module. It has some function we can use to define its accuracy, which is 1 minus the error, the modules we are combining. So take an example here down. We have 1 minus into the 30%. The 30% is the error of this particular module we are combining, and then we multiply the errors of the other modules we are combining. So on average here, we can see that these are the errors. So these modules are on average 70% accurate. So when we have to come up with an answer using this formula, we can see that even though the average accuracy of these modules was around 70 or 75%, we can see that the accuracy of the combined is around 99.9%. So this one is actually not realistic. So it means that it is not accurate. This particular function is not accurate to use, so it has some solutions we can use to make it more accurate. We have Bootstrap. Bootstrap mainly addresses how to make sure that this sample represents the whole population instead of just sampling using the sample mean. This one can be done. For example, uh, sample mean done only once, but when we are using this, we do it many times using resampling with replacement the original sample. We have bagging, which is the second solution to this function of measuring the accuracy. Bagging is to create different modules using different bootstrap training sets and average their predictions to produce the final output of the module. Uh, we have some advantages of this bagging. One of them is that it reduces variance of the module, that's reducing the overfitting. And then second one is that outliers are usually omitted. Outliers are some data sets that are in one group but are not supposed to be there in that particular group. So outliers are usually omitted in the same usually omitted same way of training the bootstrapped examples. Uh, Move on, we go to random first. Random first are actually slightly modified bagging algorithm. So these random firsts are are brought up in order to improve the bagging algorithm of solving the accuracy function of this symbol learning. We have some steps to come up with this random first. The first one is that subsample the examples with replacement bootstrapping. So, for example, we have one particular group or a cluster of data. So we pick a sample from that particular group, and then for each sample that we select from that group or cluster, we choose attributes from at random, and then we build the decision trees using these random features that we choose from these samples. Can come up with a random phrase, which is actually declared decision trees, a group of declared decision trees. Uh, these random forests have some advantages and disadvantages. Among the advantages is that it works well with non-linear data, and then it lowers the risk of overfitting. Non-linear data, this one cannot be separated using a line or a mere line. A mere line cannot actually uh, separate these modules or group them to this data set and group them into different clusters or groups. And then disadvantages is that it is slow training, and then not suitable for linear methods with a lot of sparse features. So and move on to support vector machines, SVM. These ones are supervised learning algorithm that used for classification and regression. SVM actually aims at the optimal hyperlink and separates classes with the largest margin. We have some types of classification. We have correct classification, maximizing the margin, uh, and then in outliers, and then nonlinear hyperplane. This one is not done manually, but it's done by the kernel function. The kernel function defines the inner products in the transformed space, and then defines the similarities and then defines the similarities in the transformed space. Converts converts not separable problem. So this one, for example, let's say we have some data set that is in a round form, so we cannot use a mere line to separate it. So we have some function that is z is equal to x squared plus y squared. So that is not mistaken the function of a circle. So we can use that, and then we can separate it using the can use that and then separate it using a mere line. So it converts the separable to non-separable problem. So we have two types of margins. First, the hard margin, which assumes that data is linearly separable and does not tolerate misclassification. And then the soft margin allows some misclassification for better generalization. Talk about the evaluation metrics. You have to do evaluation metrics, which is classification and for regression. Talk about the classification. That's actually a precision, the recall, and then for regression, have mean squared error or error squared. K-means, talk about the K-means. K-means the algorithm for clustering the dataset. It has some strengths or weaknesses. Uh, One of them is that it is simple among the strengths, simple and easy to understand and implement, and then it is considered a linear algorithm. And then among the weaknesses, that it's only applicable if the mean is defined. Uh, Second one is that the algorithm is sensitive to outliers. So we have application and validation. That means SVM linearity and regression. Linearity actually determines that whether SVM can separate data directly, and then supports learn about the regression tasks like predicting values. So regression is actually all about predicting the values, while the linearity can separate data directly. So have the PCA, the principal component analysis. The goal is actually to reduce the dimensionality of the data while keeping information loose and minimum. Has some applications where we have the image compression, pre-processing, uh, pre-processing step for classification. We have the facial recognition, data visualization, and then to move on to have the trade-off between the bias and variance. Actually, talk about the bias is the error due to overly simple model assumptions. For example, if it is favored, or you have you have the variance. This error is due to model sensitivity due to data classification. So solve this trade-off between the bias and variance. Uh, the best point is that to find the spot between the bias and variance. So this is actually in simple terms the mean between this bias and variance trade-off. Thank you. That's all about the module 5, 6, and 7 for diploma in machine